Hi, I'm Miriam,
Hi, I'm Grace.
And I'm Kiera.
and we are studying the effects of caffeine exposure and withdrawal on the T-therm 000135550 gene expression, feeding and growth of Tetrahymena thermophila. And we use Tetrahymena thermophila because they are small, single-celled model organism. And in previous experiments, caffeine has been shown to be a stimulant for the cells, and it has also been shown that other organisms grow a dependence on caffeine after long-term exposure. And so we just wanted to see what the exposure would do to them. So our hypothesis was that long-term exposure would upregulate the T-therm gene and increase the activity of these cells. So to do this, we first had to find a primer for the T-therm gene, which we did by using the IDT DNAS oligoionizer software that was given to us by Dr. Ottohit. And then we did a sock culture with NEF media, and then our experimental and controls were done in SPP media, and our experimental had 0.1 millimolar of caffeine in it and was about 1 milliliter. And they were in that for 3 days, and then we transferred them to a media with no caffeine, and they were that for 12 to 24 hours. And so it was a 12 to 24 hour withdrawal. And after that, we did an RNA extraction, which was done by using Kugin's RNase mini kits. And then we had to do a reverse transcription using revert8-RT enzyme. And then we had to do a quantitative PCR, which we did using PowerUp Cyber Master Mix. And we used a BTU1 gene as our control. And finally, we had to do a cell and feeding assays, which were done with hemocytometers. And our feeding assay was also done with India ink, so we could see the feeding vacuoles.
All right. In our results, figure 1 and 2 show our experimental chemical of choice. Thank you, by the way, to the chemistry department for providing our pure caffeine, as well as one of our own pictures of our Tetrahymena. Figure 3 shows the results of our feeding assay and the average number of food vacuoles per cell for the control and experimental groups. P equaled 2.12 times 10 to the negative 6 with an N value of 50, which means that the value is considered significant. Figure 4 shows the result of our growth curve and our number of cells per milliliter of media. Our p-values were 0.170, 0.289, and 0.250 respectively for 6, 12, and 24 hours. Since all of these values were above 0.05, even though there's a visible difference between the growth curves, we cannot call these values significant. And finally, figure 5 shows the fold change values between our control and experimental genes.
Based on our results, we can reach several conclusions. The cell counts were insignificant at all 3 of their time conditions due to their p-values being higher than 0.05. There was a positive fold change value between our target gene, T-therm, and our control gene, BTU1, meaning that our target gene was upregulated within the caffeine-treated Tetrahymena. Feeding assay results were also significant with a p-value of 2.12 times 10 to the negative 6, which is much smaller than 0.05. With these results, we can agree with our hypothesis regarding the T-therm gene expression increasing when exposed to caffeine and then withdrawn, and within our feeding behavior as well, but it disagrees with our hypothesis related to cell growth. Due to the COVID-19 pandemic, our lab time was limited than what it normally would be, so there were fewer replicates than we would have liked to perform, and performing more would have resulted in more data that we would have been able to analyze. Thank you.
you.
Thank you.